Bismillahirrahmanirrahim. Today our topic is cache write policies. On 17th of December, we have talked about cache coherence, and we have already discussed these policies. But some students, like international student from Afghanistan, they asked me to revise this topic, so I am revising this again. Okay, so we have two types of processing. One is single processor, like sequential processing. So for sequential processing, we have uh, three types of write policies: write through, write back, and write around. Then write around has write no allocate and write allocate on write. So we have almost four types of write policies. But in case of multiple processor, when we have more than one processor and each processor has its own cache, then the problem of cache coherence um, came to existent. So in order to handle cache coherence problem, we have these four write policies: write invalidate, write update. Then each of this is write invalidate, write through, write invalidate, write back. So if we learn about write through and write back here, it will be used here. First is the simple one, write through. It different write policies. We know that we have a cache and a processor. This is processor CPU, and this is a cache, and this is the main memory. This cache and this is main memory. So suppose a line from cache from main memory is copied to the cache, and processor wants some addition in it. For example, a value here is 7 and came to cache, and processor have updated its value to 8. So what this is some updation. Now the processor want to write this latest value. Our processor is going to increment to 9, 10, and 11. So what processor do in write through policy? When processor changes some value in the cache, it directly make the changes in the main memory. So such type of write policy making changes in the cache as well as in the main memory at the same time, this type of writing is called write through policy. So the advantage of this policy is that the value in the cache and the main memory are always consistent. There is no inconsistency. This is advantage of write through policy. On other hand, the disadvantage is that every time with every change in the cache, you have to send some data to the main memory again and again. So there is a traffic problem because this takes time to send data here and there again and again. So this is the disadvantage of write through policy. The second one is write back. In write back, suppose this is cache and this is main memory. The value is 7, just came here to cache, and cache want and increment it to 8, then 9, then 10, and 11. So the cache when first time increment this value does not send any update to the cache. Instead, it uh, continues its processing on this process and make a dirty bit that I have updated this value, and until it reaches to its final position to the end of the process. Suppose the final value is written into the main memory. So the advantage is that it controls the traffic problem, but the disadvantage is during its execution, the data between the among the main memory and the cache, the value are inconsistent. For example, here the value is 8, here is 7, here it is 9, here is 7, here is it is 10, and here is 7. So, this is the write back policy. So, in write back policy, the cache is the cache, the value in the cache is changed without updating it in the main memory. The value in the main memory is updated only once. Okay, whereas in the write-through cache, it is updated every time with any change in the cache. Okay, the third one is write-through. This was all about uh, when we read something from the cache, from the main memory to cache, or then from cache to main memory. Okay, there are two concepts we already know about that. This is cache hit and cache miss. Cache hit when data is found in cache, or cache miss when data is not found in cache. Next one is write around. Before talking about the write around, let's talk about write miss. What is write miss? Suppose I want to write some data into the cache, the main memory. If the data is already found in the cache, this is cache write. If the data is not found in the cache, this is called write miss. For example, I want to update the value. I want to write here 7. I will see this memory location in the cache. If this memory location is in the cache, is not present in the cache, so such instance is called write miss. The processor is willing to write to an address to the main memory, but the address is not in the cache. So this situation is called write miss. So write around is concerned with such type of situation for writing a data. In write around, there are two types: uh, write no allocate and write allocate or write. Here the CPU directly make, for example, the CPU wants to write 3 here at this line. For example, this is line number 9. The CPU want to write the value x is equal to 3 here. The value is not present in the first. CPU will check this block number 9 here. If it's not present, write miss occurs. So in such case, the value will be directly written to the main memory. So CPU want to write x is equal to 3 to block number, to this line number 9 or block number 9. So there are two possibilities. First, CPU write here in the main memory and the value is copied to the cache. X is equal to 3 here. Such type of writing is called allocate on write. The writing is done to the main memory and a copy is sent to the cache. And the second one where we write into the main memory but no copy is sent back to the cache. Such type of writing is called uh, write-no-allocate. Okay, we already have taken one lecture on this, so I don't like to go in further detail. Summary, we have write through is about reading and making changes in it. So the data is present in the cache. So the cache, if we edit with every edit, every update in the cache, the results are sent back to the main memory. Where in write back, this is sent just only once. Then write around is about the writing only. So if I want to write some data to the some line number in the main memory and the line number does not exist in the cache, so the write around directly take place at the main memory. So if it also update sent a copy to cache, called this one allocate on write. Otherwise it is called write-no-allocate. Okay, before talking to the next four write fallacies, let's talk about cache coherence problem again. Suppose this is a main memory and a value x is equal to 90. This value has been accessed by processor 1. A copy is sent in cache C1. X is equal to 90. Suppose an increment operator updated it to 91. Here is another processor, it copy the value 90. Suppose there is a decrement operator and it decrement the value to 89. Here is another processor, for example, it takes the value 90 from the main memory and it increment the value by 5 to 95. So here the value x is 95, here it is 89, and here it is 91, while in the main memory the value is 90. Such circumstances, such instant is called cache coherence problem. The data is inconsistent among the processor and the main memory. So how to handle this? We have these cache write policies. So the first one is write invalidate. Then write invalidate has two types, write through and write back. The second one is write update and it also has two types, write through and write back. Okay. Suppose this is a write invalidate. Suppose x value is 90. A processor this processor got its value 90, this also got its value is 90, and this also gets its value 90. Suppose one of these processors start incrementing this value, changing this value, so it changed its value, it's 91. So this processor will send a signal to the other processor who are sharing this value that this value is invalidate. He will send here a value that this value is invalid. So this processor could not write these value. Only one processor can write. So this processor can only read this value. So now it makes the changes to 92 to 93, and the final value is sent to the main memory. X is equal to 93 as well as to the parallel processors. Such type of writing policy is called write invalidate, write back, because the value, when it changed the value to 91, it did not change in the main memory. When changed it to 92, the value in the main memory was not changed. The main value in the main memory was only once changed, once time. So such type of write policy is called write invalidate, write back. This one. Now, if this processor start editing, changing the value, it's 91. So the first task is to send an invalidate signal to the other processor. This is called write invalidate policy. And the second one is with every change, it also update the value here in the main memory. So the value will be changed into 91, then into 92, and then into 93. So with every change in this processor, the value is also changed here. So this is write invalidate, write throw. Okay, these are some concept. Multiple readers. All processor can read, but only one writer. Only processor one in our example. Any processor can write, but only one processor can write at the same time. When write is required, other caches are uh, up the line are invalidated. Okay, and some data is written by one cache, the other are invalid. Right, processor then has exclusive, means cheap access until line is required by another processor. The one processor who have started the writing, it can make changes with exclusive. Mostly you are used in Pentium 4 and PowerPC. And this is called messy. Messy means a line would be either modified by, modify means it has been changed by another processor, or exclusive. Exclusive mean I can change this value. Any processor can start editing, writing on it. Shared means this copy has been shared with multiple processor. And invalid means data cannot be changed by this processor. So such type of processors are messy. Okay, now the write update. Suppose this value is 90, copied here is 90, copied here is 90, and copied here is 90. Now suppose the processor P3 have started working on it, or any processor can start working on it. Suppose this processor has changed the value to 95. So it will send an update to all these processors, 95 here and 95 here. So the communication with the cache, among the cache, is write update. The value is updated. Now, if it changes, the change also came here, it becomes 95. Such type of cache is called write update, write throw. So the next value will be, suppose increment by 5 again, it makes the value 100. The value will be 100, and the value here will be 100. Suppose it also send the value here. So this is write throw, because changes in the cache also makes changes in the main memory. Suppose now processor P1 have started some work on it, and it make the value is 101. So it will send the value here 101, also here is 101. Suppose it is write through, so it will also send the value as 101. So such type of processor is write policy is called write update, write through. Now, if this updates is shared among these cache, but the value at the main memory is just sent only once. For example, this have started the value, and when it reached 100, x value was still 90 in the main memory, but it stopped the processing, so it makes it 100 here. Then this processor have starts. Now, for example, it makes it to 102, to 103, to 1054, and so on. And last value is 104. Only the last value came here. So such type of processor is called writing policy is called write update write back policy. Okay. So there are the two types of write update cache. Okay, this is just some again. Can multiple processor readers and writers, because you know that the value is updated among all the cache, so every cache can start writing on it because the value among the cache are consistent. When a processor wishes to update a shared line, the word to be updated is distributed among the cache. Some system use a mix of both write invalidate and write update mechanisms. Okay, thank you so much.